Hi, welcome to this session on Enterprise Manager for MySQL. My name is Mark Leith. I'm a Senior Software Development Manager with the MySQL group at Oracle. I work on the Enterprise Tools team, which leads two software projects, the first being the MySQL Enterprise Monitor product, and this new product called Enterprise Manager for MySQL, a new plugin that we've developed for the Enterprise Manager framework. So hopefully you've already downloaded the Handson Lab VM and started it up, and I hope you've all run startall.sh, this script here. It takes some time for Enterprise Manager to start up, so if you haven't done that yet, then start it up now and catch up. All of the credentials are listed here in the README. For the OS, there's both an Oracle and a root user. They both have the same password as well as EM with the sysman user. And MySQL's root user has welcome1 as the password as well. MySQL should already be running on the system. Just to check, we can try and make a quick connection to it. And you can see that we're up. And we should also have the application server up and running now if you've run the startall.sh script. So let's quickly check that. And you can see the app server's up and running as well. Finally, there's this manual, which is the playbook essentially for the Handson Lab. You can see that this was originally written by Carlos Proal, who is actually one of the senior developers on our team, and led the development for the Enterprise Manager plugin. To quickly take a look at what we'll be running through, we'll look at the table of contents. So first of all, we'll talk a little bit about the overview of the plugin itself. We can skip most of the startup. Hopefully all of that's been done already by you. And then we'll look at the plugin itself, how you import it, and check its deployment status. We'll go through adding a MySQL database target. We'll add a little bit of stress to that target as well, just to see some activity. Then we'll run through the metrics and configuration metrics that have been implemented within this first version of the plugin, and run through the dashboards that have been exposed and show a lot of the metrics that are being collected. So let's look a little bit at the introduction and the overview of the Enterprise Manager plugin for MySQL. First of all, it is a true plugin to Enterprise Manager, so you download it through the Extensibility Exchange and self-update. The plugin only supports versions EM 12c, R4 and greater, and it comes as part of the MySQL Enterprise subscription. So if you're not a MySQL Enterprise customer, then you'll need to get a subscription to have the ability to use the plugin. So let me zoom in a little bit here. The architecture of the plugin itself is as you'd expect as any normal Enterprise Manager plugin. So the plugin gets deployed out on the OMS, and then you deploy it out to the management agents. And then from each management agent that has the plugin deployed on, you can then monitor a MySQL database, have all of its metrics collected, and it then shares them back with the OMS itself. The features, it supports MySQL versions 5.5 and higher. Oh, went a bit far. And it supports AutoDiscovery within the EM framework, so we actually go and look for MySQL databases that aren't being monitored. And then for the first version, we have implemented things like availability monitoring. Everybody wants to know when their databases are up or down, and configuration and runtime metrics collections, as well as performance dashboards, and you can actually change thresholds and things like that on metrics as well. So hopefully we can skip these, but if you haven't downloaded already and you want to do this at a later time, you can download one of the official VM templates from here. The credentials are as I outlined earlier on. You'd want to install a MySQL database if you're doing this from scratch and set its credentials appropriately. You'd start up the environment, and again, hopefully you've got all of this done. There's some scripts that are on the desktop itself, so you can start just individual parts of the OMS, like the agent or the database, and stop all of those. And then there's this stress MySQL db.sh, which we use to actually generate some traffic against the database so that you can see some traffic in the UI as well. To start the cloud control environment, like I mentioned earlier, you just run this start all.sh and that will start everything up for you. And hopefully that's all been done now. And then, as I said, you verify the setup. So you go and check that the database or the OMS is actually up and running. So let's log into the database or the OMS, sorry, and start looking at the plugin itself. So the login is sysman and the password is welcome1. And hopefully that gets you logged in to the system and you should see the overview come up. Can take a little bit of time. So we've got a number of targets that are already being monitored by the OMS. None of those are MySQL database targets to quickly look. It's just the general targets that are installed by default. When you want to install the plugin, you go to extensibility and you go to self-update first and foremost. So self-update is the inbuilt update mechanism from Oracle Enterprise Manager. The plugin itself will be in the plugins section. So if I sort this, you can see that there is a MySQL database plugin available. It's already been imported onto your system. We did that as part of the Handson Lab setup. It's just saves a little bit of time. But what you'd normally see here is that the plugin is available for download. You'd click on the plugin, you'd click download, and it will download the plugin into your system for you. Once it's downloaded, then you go to the plugins section of the OMS. And we're listed under the databases. So you'll see the MySQL database plugin here. From here, you would then deploy it on the management servers first of all. And then you deploy it on any agent that you want to actually monitor a MySQL database from. But you can see that we already have it deployed on the OMS, and we have it deployed already on one management agent, which is the agent that's installed on the VM itself. From here, you can actually check whether deployment is successful or not. If you do have problems with it, you can drill into each actual deployment itself and check the status of it and view logs if there are problems with it. So once all of that's done, you should be ready to start adding targets to the OMS to actually start monitoring your databases. There's two ways you can do that. You can either configure AutoDiscovery or you can add the targets manually. To configure the AutoDiscovery, you'll see there's this Discovery Advanced Modules. You'll see an Oracle MySQL discovery there. If you pick that, you then add that discovery module to the agents that you want to deploy it out to. So basically to the agents that you'd like to actually do monitoring of MySQL servers. Perhaps you've got agents that are installed out on your MySQL servers themselves. So you'd pick every agent that you want to add it to. We already have it deployed to this agent host on this VM so that you don't have to wait for that. So you can see that we do already have it configured. And then to go and check the discovery results, you'd see by agent the discovered targets. You can see there's been 7 here. And you can see that we have a MySQL database that's been discovered itself. Now to quickly run through what we're actually doing here. What we essentially do is we go and scan the process list for any MySQLD like process. So we're looking for a process that is like MySQLD. And if we find one of those processes, then we try and look at the arguments of the process itself to pull out some of the unique things that a process has, or a MySQLD process has. So for instance, things like the data, that is something that has to be unique per MySQL instance, and things like the socket variable itself, how we connect to that instance. So you can see in this case, we've detected an instance running with this socket on this host, this var lib MySQL sock. That is essentially this process that we've detected running on this machine. Once you have things that are discovered, you can then promote them from there. We fill in some of the details that we've discovered, so you can see that we've already filled in the sock, and we all give the target a name, which is generally the host name first and foremost, and then either the port or the socket that we discover afterwards as a delimiter for the target name itself, because we can actually monitor more than one MySQL instance from a single agent on a single host if you'd like to as well. So we fill in the details for this. As I mentioned, the user is root. We'll use root. You can use a user that has less privileges. They're all defined in the manual, so you only need things like the process privilege, usage of course, select globally. If you want to monitor replication, then things like replication client, so that you can see show slave status and those kinds of commands. But for now, we use root. It's nice and convenient, and the password is welcome1 repeated. We already know that we're on localhost because we've discovered this instance on this agent, and we already know that we'll connect via the socket file. You could use a port or a socket. It doesn't matter which one you use. And then once you have all of that filled in, you then promote the target itself. So EM will go through the process of pushing down the target configuration down to the agent, and eventually says that it's completed successfully. I don't want to remember passwords. The second way to add a target, and we won't do this, but I can run you through the process, is just to add them manually. So you add a target declaratively. You pick the MySQL database target type. You pick the monitoring agent that you want to add the target from. So in this case, it would be the local agent again. And then you add it manually. You get the chance to give it whatever target name you want to when you use this way, and you fill in the rest of the details yourself as well. So it would be a user with enough privileges to do the monitoring itself. The host, it doesn't have to be localhost. You can actually monitor an instance remotely from an agent as well if you'd like. And then either the port or the socket that you're connecting to. Socket is only useful on localhost, of course, but if you're using some remote host, then you'd put in the database port and you'd click OK, and off it will go and start monitoring the process, the database from there. So let's go and look back at the targets again. We should see a database target. You can see that here. And you can filter them with the MySQL database search here. So you can see that we've got a database being monitored and its target status is up. So let's go and look at the actual database target itself. So this is the new home screen for the plugin itself. The home screen is a real-time dashboard. So rather than looking at the history data that's available in the OMS itself, what we actually do for a lot of the statistics, all of these statistics here at least, we actually go and pull the data on a real-time basis. So we poll the agent interactively every minute from the OMS, and we pull that back in a real-time way so that you can monitor the current status of the database itself. So down on the left-hand side, we have some historical and configuration data. We have the availability history from the last 7 days for the database itself. Luckily, you can see we're 100% up, but it's only a very short time. And you can drill in from the monitoring overview, the status history of the availability of the instance itself. We have a high-level configuration summary, so which host the database is on, its version, how you connect to it, its major directories, its base directory, where it's installed to, where its data is, and where its temporary files go, how long it's been up, and who's actually monitoring it. Like I said earlier, this could be a completely different agent on a completely different host, so we show both of these things. Then over here we have the interactive graphs. They're a bit empty at the moment, so we'll go back to those in a minute. But first, let's drill into all of the metrics that we can collect. So you go to the all metrics page itself, this all metrics page, and you can see all of the different kinds of metrics that we collect. So they're broken down in logical sections, essentially. So what we actually do under the covers is we go and execute a number of statements, the typical monitoring statements that most DBAs do. So they could be things like show slave status, or show global status, show global variables, the things that give you a lot of the counter-based metrics back. We then, within the plugin, we break them down into these logical sections of different metrics. So to give an example, we have the binary logs and we give you a count and size. For connection activity, we give the high-level counters for certain things around collections. Things like aborted clients, how many bytes have been sent and received, how many connections there have been, and the max number of connections. To look at other things like the replication slave activity, we break down a lot of the output of, for instance, show slave status, so that you can drill into the last errors. You can see whether the slaves are up and running or not, and a lot of the counter data for a slave, and other things. So we can break down slow query logs, threads and thread cache and table caching activity and all of those kind of things. Now the metric data itself is collected on a every 5-minute basis. That's done by default to try and minimize the overhead of the OMS with all of its collection activity across a number of instances. You can actually change that if you want to as well. You can modify it on a per metric basis if you'd like. But you can see that we're already monitoring a number of metrics just out of the box. So for things like the thread activity, we can see we've only got one thread actually collected at the moment. We've had 1,562 over some period of time. And that's actually a delta as well. So what we do with a lot of the counter-based metrics within the plugin is we compute the delta from now and now minus 1, essentially. So from the collection that we took by default 5 minutes ago and the collection that we take now, for a lot of the metrics that are counters, we will compute those deltas and they'll show you that it's a delta in the name of the variable itself. So I'm going to drill into connection activity actually to give a quick example. So we don't set any thresholds on any of these metrics by default yet. We're looking into things like the compliance framework to be able to do certain levels of background monitoring and alerting. But for this first version, we decided to first and foremost expose all of these metrics and get people using them, and then we'll build upon that framework to then start monitoring these things in the background automatically. But that doesn't actually stop you from altering thresholds yourself as well. We do allow that from within the plugin. So if you want to try and monitor for certain things, you can drill into each one of the metric properties themselves and check for certain values. So you can see the history range. Of course, this is quite empty at the moment, but if you had been monitoring for a larger time, you'd see whether you've had any spikes, for example, in aborted connections. And you can modify the thresholds from there. So if you want to, for instance, raise a warning if you have one aborted connection and a critical if you have 100 within a specific interval, then you can test it from there. You can test the threshold to see over the lifetime of the metric data that you've got at least whether it would be triggered or not, and then you could save the thresholds from there. So in this case, we want to check whether there are any aborted connections. Then you can quickly do that with just setting a threshold on the metrics themselves. There's over 500 different metrics, and we do break them down in a fairly logical way. So binary logs themselves, actually DML statement activity, so things like the types of statements that are running across the MySQL instance, broken down by the actual statement type. Handler activity, which is actually the interaction between the SQL layer and the storage engine layers. So you can see how rows are read or how commits happen, how many commits happen, how rows are read via indexes or via scan, those kind of statistics. There's a lot of InnoDB statistics as well, broken down in InnoDB's case into the various different subsections or subsections of the plugin itself. So things like the buffer pool activity in the or how the buffer pool is being used, the insert buffer, how IO is being used, how the redo log is being used, its own thread background activity and transaction activity. So things like how many transactions are open, how many rows are currently locked, the transaction history, how much memory is being used by locks, those kind of statistics. So there is a lot to drill in here from, and I won't show them all, but you do some good going through each of these metrics and just browsing around to see what you can get. There is, as I mentioned, over 500 different things that you can monitor from here. If you are having any problems, it's worth pointing out that there is this metric collection errors. If you do find that certain graphs aren't being updated or anything like that, then you can go here and see if there are any problems collecting the data itself. Luckily, we don't have any errors at the moment, which is a good thing. But I just wanted to point that out. And like I said, there's the status history, which basically looks at the availability data that we collect and lets you see a breakdown of its status or availability status over time, and lets you drill into problems from there. Now, finally, with the metrics and collections, there are configuration metrics that are implemented as well. So configuration, where normal metrics are the runtime data for a MySQL database, the configuration metrics instead of the actual config of the MySQL database itself. So the runtime metrics are largely based off things like show global status, show InnoDB status, and show slave status. The configuration metrics are purely based off show global variables. But again, we break those down into the logical sections. So where with show global variables, you'd get a long output with things intermixed depending on the names of the variables themselves. We actually break them down by the various subsystems in the MySQL database itself. So you can see again, binary logs are represented on their own, and all of the variables related with binary logs, and there are quite a few, are exposed just in that one configuration metric. And similar with things like character sets, the environment, which are where we're installed to, and environmental things, how the host cache is configured, InnoDB's full configuration. Again, there's a lot of different variables that you can drill into from there. But we also break out specific things like full text within InnoDB and memcached configuration within InnoDB. And then other things like how logging is set up on the database server, networking itself, performance schemas configuration, how a replication slave is configured. This is stuff that comes from show slave status again, although it is actually the configuration rather than the runtime metrics. And other things like table configuration, thread pools, threads, all of the various parts of a MySQL server broken down logically for you. We make use of the configuration framework as well, so you can actually compare configurations across a couple of different instances. For instance, we don't have that on here, but that is possible with the plugin itself. And you can look at the history of configuration. So it's actually, whilst we're looking at the last collected values in this case, you can actually go back and look at the history of changes with the collections as well. So actually drilling into the how configuration changes over time. There's nothing that's actually changed so much. It's just the platform and operating system in these cases, and relationship changes. But if you have some system variable that changes over time, and they're snapshotted every 24 hours, by the way, so I can't do a very quick one as an example here. But if you do have configuration variables that change over time, then you can drill in from here and see exactly what changed and from what value to what value that they have changed as well. So let's quickly go back to the home screen. Now, hopefully we should have some activity that's happened. Have configuration variables that change over time, then you can drill in from here and see exactly what changed and from what value to what value that they have changed as well. So let's quickly go back to the home screen. Now, hopefully we should have some activity that's happened. There we go. So you can see that some data has been collected, and we're starting to see some activity on the database itself. So to quickly run through the statistics on the overview page, we have what we think are the top KPI type counters that a lot of DBAs will want to look at. So there's really three major things that any administrator of a database wants to look at. Those things are the concurrency on the system, the throughput on the system, and the response time of the system. So with concurrency, we have the connections themselves, so broken down by those that are running, those that are connected, and those that are actually cached with the thread cache. We have the response time, which actually records the same output as the availability ping. So what the availability ping and the response time both do is they make a full connection to the database. They then execute a very simple ping-like select query, and then they disconnect from the database. And the time it takes to connect to the database and actually get the response to the very simple ping-like connect or select query are what we then record as the response time as well. So it's not the the overall response time of all queries. It's the overall response time of making a connection and executing some very quick query. But it is actually a very good indicator of response times for a lot of web-based applications and clients where you do make a lot of very quick connections, execute one or a few statements, and then disconnect very quickly. With the transaction activity and statement activity, what we do is we break them down by transactional statements. So whether we're tracking things like a begin, a commit, a rollback, those kind of transactions, you can see that we're not doing any at all on this system. And then we break down the statement activity by the different types of statements that are being executed. So you'll see things like all insert statements. You'll see things like deletes and how many selects or call statements, the general DML breakdown of the database activity itself. I was trying to hover there so you can see all the different types of statements that are being executed. Then with the row activity, we look instead at how rows are being accessed across that handler layer that I talked about. So not just the connections and the DML and the response times of that, but we're adding a little bit more onto those top 3 KPIs by looking at how the rows are being accessed across the storage engine layer. So you can see this top row is actually rows read via a full table scan. It's actually not the kind of access that you want. This is bad. But also rows read via indexes and how rows are being written across the handler layer as well. So writes are general inserts, updates and deletes are broken out themselves. So you can see we have quite a high write and read ratio, insert and select ratio, but pretty much no updates and deletes, and that's reflected pretty well over here in terms of the statements too. And finally, we have the Nodb buffer pool usage. So we break down the overall buffer pool usage based on the number of pages within the buffer pool itself. So you can see that we have a lot of data pages that are already defined here, and then only a relatively small amount of free data that's available. So those are what we think are, pretty much the top KPI-like values for any DBA: the concurrency, throughput, response times, how things are being read in the database, especially via full scans, and how caching is happening within the database. Then finally, we've got this incidents and problems. If you set any threshold on any of the metrics, then they will show up here if they've been broken. So you can drill into the metric problems from there, see their history, see when they occurred, and try and find out what the problems are from there. So this was as I said, the real interactive real-time dashboard. But we also have a number of dashboards that have been implemented to actually show historical data as well. So to one by one go through these, first of all, there's the connections dashboard. What this does is it takes some of the high-level metrics around connections themselves and some of the configuration, and this is something that we do through all of the performance dashboards. So whilst we show a lot of the metrics around some specific area, will also side by side on each of the dashboards show the configuration for the things that are related to those metrics. So with connections, we again see the one that we saw on the front home page, the overall connections connected, running and cached. But we also see the connections over time. So this is the delta of how many connections happened between the intervals of collections themselves. We see that network usage, so how many bytes are sent versus received across the network. Whether any threads are slow at launching, and you can set the slow launch time, which you see here, for example. And then those connections aborted, so where we set that threshold earlier, looking at the aborted connects over time, and the maximum number of used connections over time. So it's pretty much 37 is the most we've used at any point in time. But the idea with these is to be able to see the values over some history of time. By default, this shows the last day, although we don't have a day's worth of data here yet. But you can also drill into the last week or the last month as well, depending on if you're saving data for that long, essentially. So that's connections. Where with statements, we break down again the kinds of statements that are actually happening. And again, their configuration of different statements. So prepared statement activity, how the optimizer deals with statements, those kind of configuration values. But then we have a slightly different layout with this one. The idea is being able to stack up these kinds of statistics over a period of time and then view them as a timeline across all of the different statistics. So you can correlate then between, for instance, some DML statements to how many rows were actually read as part of that. So you might see some spike where you've got a huge amount of statements that are being executed, and then correlationally, a number of or a huge amount of row activity that happens at around about the same time. You can see where those things come from. So with statements, we're looking at that DML activity and transactions like we did on the front page, but then correlating it to things like the row activity and index usage ratio. So you can see the ratio of index usage is actually quite bad. We should be at 100% here rather than a 0.8% or 0.9% that we've got here. And then how temporary tables are being used for those statements and how those statements are sorting. They're just the very high level metrics related to statements and their correlational activity that happens because of them in many ways. With the Nodb buffer pool, we do something fairly similar with the overview. So we're looking at the stacked values of statistics over time. This current pages used is the only real-time graph that's on one of these performance pages actually at the moment, and it's the same one as on the home page, but just here because it's the same kind of metric. We showed the Nodb configuration again, and then we drill into all of the different statistics around the buffer pool. So you have things like how the buffer pool is being used over time in terms of actual data that's being cached versus dirty data. That's data that's waiting to be flushed in the background, for example. We have the row requests over time, so how the buffer pool is being read or written to. The page activity itself, so how pages are being read and written to and created over time. Sometimes you see a correlational effect between these two, for example, because pages equals rows at the end of the day. We see things like any waits for free pages. So that's something that can happen when you have a full buffer pool. You have a lot of dirty data, for example, maybe, or just a lot of data that's waiting to be flushed in the background. And as you try and cache more data, you have to then purge out or flush or checkpoint the data in the background to then get a free page to pull it into the buffer pool itself. So if you see spikes against this graph, for instance, you'd probably want to go in and look in at this adaptive flushing, which then tries to flush more periodically in the background to keep up with the activity that's needed to then allow not waiting for free pages to be able to cache new data in the buffer pool. You see how many pages are actually flushed over time, how many pages are latched or locked by different processes or connections. How pages are made young or not young over time. We actually split up the buffer pool into these an old list and a young list. The young list are the pages that are accessed the most, and the old list is pages that may only be accessed one or a few times. It's actually a protection against scanning an entire table and then flushing everything out of the buffer pool when you only scan it once, for example. And the number of pending operations, so how many pending reads, flushes, writes, and writes to single pages that are actually waiting to happen. Whether page read ahead is being used. And if you're using InnoDB compression, then we can show you the compressed time over time as well. So exactly how much time is being spent doing compression operations, either compressing to push to disk or uncompressing as it pulls from disk. So you can get a good idea of if people are starting to spend more and more time actually just doing compression operations to pull things in and out of the buffer pool. With the InnoDB file I/O, we break down the different file I/O statistics for InnoDB itself. So we look at its actual data file I/O activity, how many bytes are being written or read from the data files themselves, and the operations. So they might be correlational again, but it shows that how many actual operations versus actual bytes are actually being read or written themselves. All of the different file I/O variables, and there are a lot of those in InnoDB. And then we look at some other statistics. So we look into things like the double write buffer activity, how many reads and writes and pages written are actually being done for the double write. Double write in InnoDB is a process that saves having torn pages when you write to a file system and maybe crash in between, for example. Then we have the redo log, so the transactional redo logs and how they're using I/O, again broken down by either bytes themselves or by operations. Whether we actually rate or wait to write to the redo log, the pending I/O counters again, pending flushes again, so flushes from the buffer pool to the logs, those kinds of things, or to the data files. And then the number of open files that InnoDB has overall as well. So this can change over time depending on your InnoDB open files. We have a very small list in our idle instance, for example. Then we have tables and rows. So this more looks at the how tables are being used within the MySQL instance. So you can see how many actual tables are open over some period of time. You can see that this was when we were doing benchmarking with MySQL Slap, and we opened a lot of tables and they were used, and then they finally get closed after some period of time. And the open table definitions. So table definitions are the metadata about the tables, and then the actual table handles themselves that are open. You can see temporary tables again on this one. So the idea and the reason that you see these graphs twice in a couple of different performance pages are because they are correlationally right to look at in those two different areas. So whilst we only drill into a certain specific area of the database server, like how tables are being opened, for example, in this case, we also want to see how many temporary tables are being opened, because it's still table usage within the database server. So you can see those statistics alongside the other open table statistics. You can see how tables are being locked over time. So these are full table locks, for example, not row locks in InnoDB. You can see that table scan ratio, the index usage ratio again, and how rows are being read and written and sorted, and actual, in this case, drilling in a bit more into table sorts as well, or sorts of data. So you can see the types of sort that are happening. In these cases, they're sorted as part of a scan operation. You can see the number of rows that were sorted. So whilst we had 4 here, you also see that they had 116 rows, so roughly 25, 29 maybe rows that are sorted per statement. and whether we've done any sort merge passes. So whether the buffer on disk or the buffer itself in memory was large enough to do the sort of those rows, and it is. We didn't have any spikes here that say that we had a sort merge pass. And if you do get spikes there, then you can quickly see it and then go and change the sort merge passes configuration variable as well. And finally, the query cache. Now, the query cache is an area of the MySQL server that some people find extremely useful. Some people find an extreme bottleneck. For example, it has a central mutex within the server that locks for each connection that uses it, so it can be a concurrency bottleneck. But in certain cases, particularly people that use MySQL to do some kind of data warehousing or have a relatively small number of clients that connect and throughput, for example, but large, complex analytical queries that generally run the same on the same kind of data set because they operate on the same data with those things. Things get imported on a relatively infrequent basis. But in those cases, then it can be extremely useful. So we've added a performance dashboard for that as well, and you can see how it's performing for you over time. So in this case, actually what we can see is there's 0 hits, 0 inserts, a whole bunch of statements that were not cached, but we do have it all. We actually have it turned off in this case, so you don't see the rest of the activity here. If it's turned on, then you do get to see some useful statistics. So you can see how many queries are actually being cached in the query cache, how much free memory it has, some fragmentation type statistics. So you can see the average free block size and the number of free blocks that are in the cache as well, and the low memory prunes. So if you have 0 free memory and you start to see a lot of spikes in low memory prunes, and you're getting some decent efficiency in terms of hits and the number of queries in the cache, then you may want to go and tune the actual query cache size, for example, and increase the cache to stop actually pruning, which can stall things for any concurrent statements as well. So that's the query cache. So that's the limits of the plugin infrastructure itself, if you will. So that's the dashboards that are implemented, the underlying metrics that are implemented, and the configuration data that's implemented. There's actually, believe it or not, there's 1,001 different things that are collected, and I didn't make that number up. It really is 1,001 split between both runtime metric data and configuration data itself. So whilst we haven't exposed everything, then this is the start of the plugin, and we'll build on these things over time. Now, the one final thing that I wanted to mention and show is that you can build your own group-based views and things like that based on the MySQL target type itself as well, and it does work with things like dynamic groups in Enterprise Manager. So just to quickly show that, we can give it a name, so it's our MySQL databases. We define the membership criteria, and in this case we want it to be anything that's of type MySQL database. We can do a preview of that, so we can see that our database is picked up automatically. We say OK. And then the thing I really wanted to show is that you can create any charts yourself on these metrics too. So every single metric that we collect can be pulled into a chart. So if we're not actually charting things for you by default, and you do want to see things across a group of servers and those kind of things, then you can do that as well. So let's pick a specific thing that we want to monitor. In Nodb rows updated, for example, the delta of those. You can choose how to show the chart in the group, so whether it's the targets with the two targets with the highest average or the lowest average, or the sum of all targets, for example, those kinds of things, then you can do those as well. So we've added one chart. Let's go and add another one. Let's look at a replication one. So slave activity seconds behind master is a popular one, and we'll go with the two highest again. So once you've done that, you can then build up your own dashboards of all of the different statistics that we can generate as well. We've added our group. It will automatically then, every time we add a MySQL instance, it will include that instance in the MySQL database group, and then start tracking those statistics and let you drill into the different dashboards from there. So it's very much building into the EM framework and making use of that, but then pulling all of our statistics too. So you can see their availability unknown or pending over some period of time for all of the different targets. But then drill into those dashboards as well. So you go to the charts, and you can have your own custom dashboards. This one's a little bit boring, of course, because it's working on some empty data. But you just to show that you can actually build all of those things up. So with that, we're going to go back to the slides and quickly go through the safe harbor statement, and then into any Q&A. So thanks for your time. Thanks for taking the time to download and install and try out the plugin. And please ask any questions as appropriate. Thanks.